Okay, so this is going to be part 4 of my presentation on emergency drinking water purification and long-term storage. This is going to be methods for emergency drinking water filtration or purification. So filtration versus purification. Filtration involves physically removing particulates and contaminants from the water using a barrier. With purification, in contrast to filtration, purification involves treating water to make it safe for drinking by eliminating not just particulates, but also pathogens such as viruses, bacteria, protozoa, and sometimes even chemical contaminants. But generally the solid parts, the microplastics, etc., those are what you want to filter out, because you can't purify out solid particles, just like you can't purify out chemicals using chemicals. You can filter out the chemicals, you cannot purify the chemicals out using other chemicals. If you are to assume that this is the particle in your water and this is the virus, and you're trying to use UV light to reach the virus, well, if the water is filled with particles, that UV light cannot penetrate through and reach the virus. So you might have a false sense of security if you're not filtering the water first. So I put together this chart to show you the differences between microfiltration, ultrafiltration, nanofiltration, and beyond. So you can see here that nanofiltration it's 0.001. That's what you basically need to filter out viruses. That's why most filters cannot filter out viruses. The virus particles are 0.001 microns. It's amazing they're even able to make media that can actually filter something even as large as 0.1 micron, which is still incredibly tiny. Like, they're able to manufacture to such incredible specifications. For ultrafiltration, reverse osmosis distillation, here's a few examples. So with ultrafiltration, which again, going back, is to the 0.01 micron level for pore size, which is going to filter out your protozoa and bacteria, you're looking at a device like the Survivor Filter Pro X, which is a battery powered either through AA batteries or through a USB power pack, which means you can power it through solar. That's going to give you powered filtration and some basic purification. Now, water purification, generally it's either going to be chemical, thermal, or mechanical. You also have UV for purification. So at this point, we're talking about killing the water, not cleaning the water. Cleaning the water is what we would have done in our filtration stage. Killing the water is what we're doing in a purification stage. We're making the water free of the bacteria, of the protozoa, of the viruses. So some examples of chemical purification, you're probably familiar with these. Chlorine bleach, iodine tablets. But the problem with chlorine is that it has a very, very short shelf life. Look at the shelf life, look at the best by date or the use by date on the chlorine in your laundry room. It's probably going to be about 6 months. Go look. And while you're at it, subscribe to this YouTube channel. So how it works is that the active ingredient in chlorine bleach, which is sodium hypochlorite, kills bacteria, viruses, and most types of protozoa. And how to use it, you'd usually use about 2 to 4 drops per quart of water. You let the treated water stand for at least 30 minutes before drinking. And then bleach can leave a residual taste and is not effective against all types of protozoa, such as Cryptosporidium. But the biggest problem with using chlorine is its relatively short shelf life. And it can give you a false sense of security because it'll still smell potent. It will make you think that it's working, but it's not going to do anything other than make your water taste bad and smell horrible. So instead of just storing chlorine, which is probably going to be expired by the emergency, you should consider sodium hypochlorite, which can last for years on the shelf. But the thing about sodium hypochlorite is that it's so powerful that you should not use it in the same concentration as bleach. Use sodium hypochlorite to make the bleach, which you'd use to purify the water. You wouldn't usually use sodium hypochlorite to purify the water that you're going to be drinking out of. It's like a 3-step process. And you can also make your own bleach. A few devices that allow you to use water and salt, and it turns that mixture after a few minutes using some power into a bleach solution. So your salt is never going to expire, and that can be used to create your bleach to then purify your water. So with thermal, you have a few options. You have boiling, which uses heat to kill pathogens in water, making it safe to drink. Thermal purification is usually effective against bacteria, viruses, protozoa, and you don't have to necessarily bring the water to 212 degrees. You can also use pasteurization. So with boiling, you would obviously just bring the water to a rolling boil, that's obvious, but how long? Well, at sea level, it's 1 minute. And above 5,000 feet, you should boil it for 3 minutes. It's one of the most reliable ways to purify water. It kills pathogens, including viruses, which are generally resistant to some chemical treatments. Some of the problems, though, with thermal purification is that it won't remove some chemical contaminants or particulates. It also requires a significant amount of fuel and time, and it can make the water taste flat. So you can fix that by aerating the water, by pouring the water back and forth between a couple different cups back and forth. Pasteurization. So if you don't have the ability to get the water to 212 degrees, let's say you have like an electric kettle or a 12-volt kettle, which I keep in my kit. Just plug it into your car when there's no power, and then you can boil water to have purification after you've filtered it. So you'd heat the water to 149 degrees at least, and then you'd maintain that temperature for at least 6 minutes. You can't go wrong heating it longer. You're just going to lose more and more water the longer you keep it heated through evaporation. Now, solar water pasteurization is a common method where water is placed in a clear plastic bottle or special bags and set in direct sunlight. So the water should reach about 65 degrees Celsius for effective purification. And then you have steam distillation. Now, to do steam distillation, you would boil water and direct the steam into a cooling tube or condenser. And as the steam cools, it condenses back into liquid water and is collected in a clean container. So there's a couple ways you could extract water through distillation. And one of the new ways is there's a device that you can get installed on your roof, and it is a solar-powered water generator. It pulls water just out of the air. It's like a dehumidifier, but it's self-powered. It uses solar energy to power the process for solar distillation, and then it sends the water down into your house. They might even have a portable one now where you just set it up outside and collect the water into a bowl. That's pretty cool. It's overkill because you can make your own solar still pretty easily. I have a video on how to do that, but basically just put a large bowl out, put a smaller bowl on top, and then put saran wrap over. But in that larger bowl, you have the dirty water from like your pond or a creek, and then you put the smaller bowl on top of that, and then you put the saran wrap over it. And what happens when you weight the saran wrap down is that the water collects on the saran wrap. It drips down into the top bowl because you're angling that saran wrap down into the top bowl. So the water's coming up from the dirty water underneath. It's collecting on the saran wrap. The heat from the sun is making that water collect, and then it's dripping down onto the clean bowl that is floating on top of the dirty bowl. But there's another way you can do it. And if you have power at your house, you can run a dehumidifier, or you can run your home's air conditioner. And it's very effective against a range of impurities, including heavy metals, salts, and other chemicals, in addition to pathogens. But it requires specific equipment. It's obviously energy intensive. It's not practical for large quantities of water without a dedicated setup. It makes water slowly. And then for the clean water, make sure the containers are thoroughly sanitized with bleach that's not expired, with water that's not contaminated, that is potable. And if you've ever used that container for anything other than clean, potable water, such as gray water, let alone black water, do not use it for your potable water, even if you've tried to clean it. It's not worth it. And then lastly, you have UV light sterilization. So devices such as the SteriPen utilize a UV light bulb to emit UV light. This type of ultraviolet light has a specific wavelength, typically around 254 nanometers, that is highly effective at disrupting the DNA and RNA of microorganisms. By damaging their genetic material, UV light prevents pathogens from reproducing and causing an infection. And the way to use this would be you fill a bottle or container with clear water and make sure that there's enough room in the top for the UV purification wand to penetrate down in the water. And then one last consideration is that it has a definite lifespan. It's going to give you around 8,000 treatments on average, but eventually the UV lamp will need to be replaced.